Alright guys, welcome to class today. Today we're going to have kind of two different parts to our notes. So this is the first paper that you need. We're actually going to skip the front part for now since I'm not here. Keep it though, when I get back we'll do this front page some other day. But for today, to keep our notes shorter, we're just going to do this back part that you need for the second part of our notes. Okay, so flip on over to the back part called Rationalizing the Denominator. We'll do this part. I'll let you guys practice a couple on your own, and then we'll switch over to our second part of our notes for today. All right, so rationalizing the denominator, what does that mean? So sometimes in this next topic, we're going to get answers that look something like this. And so you notice that in this answer, we have a radical or square root in the denominator bottom of our fraction. And that's considered improper form to leave your answer like that. So rationalizing is the process that we use to get the square root out of the denominator and put it back in the numerator. So we're not changing the value of the number, we're just changing how it looks. All right, so the step one when you're rationalizing is we multiply what we're given by something equal to 1. And what you use to make something equal to 1 is whatever you're trying to move. So here I'm trying to move the square root of 2. So I'm going to multiply by square root of 2 over square root of 2. All right, so square root of 2 over square root of 2, that's equal to 1 because anything divided by itself is 1. So we're just multiplying by a fancy 1. But anyways, when you're multiplying fractions, remember that you multiply across the top. So 5 times square root of 2 equals 5 square root of 2. And we multiply across the bottom. So square root of 2 times square root of 2 is square root of 4. So a couple things to remember is when you're multiplying with radicals, things that are inside the radical multiply by each other and stay inside. That's why the square root of 2 times the square root of 2 became square root of 4. Things that are outside the radical multiply with only things outside the radical and they stay outside. So things inside multiply only with things inside and stay inside. All right, so next step. Well, what is the square root of 4? 2. So this simplifies to 5 square root of 2, and then on the bottom, instead of square root of 4, we have 2. So this is our new answer. If you typed it into your calculator, it would have the same value as what we started with. This one's just written in a different form, where our square root is now in the top or numerator of our fraction. All right, let's look at another one. So this time we are trying to move the square root of 10. So we're going to multiply by square root of 10 divided by square root of 10. When we multiply with fractions, we multiply across the top. So 4 times square root of 10 is 4 root 10. Divided by, now we multiply across the bottom. Square root of 10 times square root of 10 is square root of 100 because 10 times 10 is 100. And then you ask yourself, well, what is the square root of 100? 10. So 4 root 10 over 10. And some of you may have noticed we actually could simplify just one little bit more on this one. If you're looking at the numbers just outside of the radicals, nothing inside the radical, that's 4 over 10, which is a fraction 4/10. So what's the simpler version of the fraction 4/10? 2/5, right? Because 4 divided by 2 is 2, 10 divided by 2 is 5. So 2/5 is a simplified version of 4/10. So our simple answer is 2 square root of 10 divided by 5. All right. Let's try another one. So this one, we're trying to move the square root of 3. So we're going to multiply by root 3 over root 3. Across the top, 2 times square root of 3 is 2 square root of 3. On the bottom, root 3 times root 3 is root 9. And then you ask, well, what is the square root of 9? 3. So 2 root 3 over 3, and that's your final solution. All right, you guys try 4 and 5, and then pause the video. Once you guys have had time to try it, unpause the video, we'll check it together. We'll do number 6 together, and then we'll do part 3. All right, so for number 5, you are multiplying by root 5 over root 5. So when you multiplied across the top, you would get 5 square root of 5. Across the bottom, you get square root of 25. You ask yourself, what is the square root of 25? 5. So 5, root 5 on the top. Square root of 25 is 5. And notice we have a 5 and a 5 both outside of the radical. And 5 divided by 5 is 1. So those cancel because they divide to 1. So we just have square root of 5 on this one, which is simpler than what we started with. All right, on number 5. This one you're multiplying by root 7 over root 7. So across the top, you get 2 root 7. Across the bottom, you get root 49. So you ask yourself, well, what is the square root of 49? 7. So 2 root 7 over 7. And that is our final solution because the fraction 2/7, that's as simplified as it can get. So 2 root 7 over 7 is our solution. All right, number 6. So for this one, we are multiplying by root 5 over root 5. So on the top, we have 1 square root of 5 divided by square root of 25. So we have the square root of 5 over 5 as our final solution. And also, you could still write 1 root 5 over 5. It's just that if there's not a 1 outside of the square root, it's kind of understood. It's like an invisible 1 to be there. So you can write the 1 right there, or you don't have to. It's the same thing either way. All right, so last bit, multiplying with radicals. So this should be a little bit of review from middle school, but in case it's not, or in case you have forgotten since then, just a little bit more review on how to multiply with a radical. So remember that numbers that are inside multiply by things inside and then they stay inside. Numbers that are outside multiply by things outside and they stay outside. So on this one, we have an 8 and a 4, they're both inside. So 8 times 4 is 32, and they stay inside. So root 8 times root 4 is root 32. And by the way, once I come back, we will learn how to simplify square roots and into their simplest form. And so we could simplify that one, but for now we're going to skip that part. All right, on this one we have a 3 and a 2 that are inside. So 3 times 2 is 6. So the square root of 6 is inside. We had a 2 that's outside. There's nothing else outside, so it's still just a 2 outside. So 2 root 6. For this one, we have a 2 and a 10 that's inside. So 2 times 10 is 20, so we have a square root of 20 that's inside. We have a 3 that's outside. And this, remember, invisible 1, so 3 times 1 is 3, so it's still just 3 outside. You guys try 4, pause the video. When you're finished, unpause it, and we'll check it together. All right, so on this one, the 2 and the 5, those are outside. 2 times 5 is 10, they stay outside. The 3 and the 7, those are inside. 3 times 7 is 21, so that we have root 21. We'll do number 5 together. So number 5, the 2 and the 2 are outside, so 2 times 2 is 4. The 3 and the 3 are inside, so 3 times 3 is root 9. And this one we know how to simplify a little bit more because what is the square root of 9? 3. So really this is 4 times 3, because we're replacing the root 9 with a 3. And what is 4 times 3? 12. So this one is 12. And last but not least, we have 5 root 2 all squared. So remember, when we square something, we're just multiplying it by itself. So this is 5 root 2 times 5 root 2, because squared means multiply it by itself. Pause the video. You guys try this one. Unpause it when you're ready to check. All right, so 5 and 5, that's 25. 2 and 2, that's root 4. What is the square root of 4? 2. So that's just 25 times 2, or 50. All right, so that is part 1 of your notes. We are going to be using these skills on our second part of our notes. So go ahead and find the notes that look like this. All right, so we are going to be looking at 2 different types of special triangle patterns. These are called special right triangles. Today we're just going to be looking at one of them, one of the triangle patterns that are called 45, 45, 90 triangles. So how a 45, 45, 90 triangle is made is essentially we have a square, and we know squares have right angles. And we cut that square in half diagonally. And when that happens, we end up with a triangle that has a right angle. This angle here is half of a right angle, or 45 degrees. And this angle right here is half of a right angle, or 45 degrees. So these are called 45, 45, 90 triangles because they all have one 45-degree angle, one 45-degree angle, and a 90-degree angle in them. So there are certain patterns about how the measures of their side lengths are, and we can use these patterns to find the length of missing sides. So I want you to take a second, look at these 3 triangles in this picture, and come up with what pattern do you notice about the side lengths of the right triangles. So what do you notice about these things? Do you notice any patterns? Pause the video. Look at these for a second. I want you guys to talk to your group of what you notice, and once you're done, you can unpause the video. All right. Okay, so hopefully you notice some things that are similar between each triangle. Also, I think I'm remembering that one of your triangles looks different than mine. I think on this triangle right here, yours says root 3, and this one's root 6. Which is just a different example than the one I had on here, but it's a good one. Okay, so one thing that you should notice is the 2 legs of each triangle are the same. So we call legs the sides of the triangle that are not the hypotenuse. Remember, the hypotenuse is the side that's across from or not touching the right angle. So that's the hypotenuse. So the legs are the other sides. So these 2 legs are both 5. These 2 legs are both 12. These 2 legs are both square root of 3. All right, so the legs of all these right triangles are the same as the other leg. And then what do you notice about how we get the hypotenuse based off of the leg? Well, on this first one, it's easier to notice because we have 5, 5, 5 times square root of 2. On the second triangle, we have 12, 12, 12 times square root of 2. On the third triangle, we have root 3, root 3, root 6. But remember, root 6 is really just root 3 times square root of 2, which would follow the pattern as the other ones, root 3, root 3, root 3 times square root of 2. So this is our pattern for any 45, 45, 90 triangle. What happens is the legs are always the same, so we call that x and x. And the hypotenuse is always x, or whatever your leg was, times the square root of 2. And so we can use this pattern to find missing sides in a triangle. All right, so for example, on this first one, the 3 is on a leg. which means that the other leg is also 3, which means that our hypotenuse is 3 times the square root of 2. On the next triangle, we're given the hypotenuse. So remember, the hypotenuse is the x root 2 side. So 4 root 2 that we're given is equal to x root 2. Because we want to know what is x. Because remember, x is the legs. So if we can solve for x, we solve for the legs. So we're going to get x by itself. What's happening is that right now, x is being multiplied by the square root of 2. So we're going to divide by the square root of 2 on each side to undo that multiplication. So on the right, root 2 of root 2 divides to 1, so it cancels. On the left, root 2 divided by root 2 also divides to 1, so it cancels. So we have that x is equal to 4. So each of these legs is 4. Let's look at some more examples. Here we're just going to rewrite the rule so you can reference it on the back also. So the leg is x, the leg is x, the hypotenuse is x root 2. So remember, legs are across from 45, across from 45. The hypotenuse is across from 90. Which, by the way, extra little fun fact connection, makes sense because remember on your previous test, we had that congruent angles mean that we have congruent sides. So of course those sides are going to be the same if the congruent angles are there. So that's kind of fun. All right, so on this first one, we decide, are we given a leg or are we given the hypotenuse? We're given a leg because it's across from 45. So that means that the other leg is also going to be 4, which means the hypotenuse is 4 root 2. So 4, 4, 4 root 2. All right, so for the next one, we're given the hypotenuse is 9 root 2. So the hypotenuse is always x root 2. So x root 2 equals 9 root 2. And this is going to help us solve for x. So we can divide by root 2 on both sides. Root 2 over root 2 divides to 1, so it cancels. So x equals root 2 over root 2 divides to 1, so it cancels. So 9. So x equals 9. So each of those legs is 9. So 9, 9, 9 root 2. All right. Okay, this one has some words, so let's read the problem and then we'll draw a picture. So Diego's house has a walkway diagonally through his square backyard. He wants to line the fence of the backyard with flowers. If the walkway is 36 feet long, how long is one side of the fence? All right, so here's his square backyard. There is a walkway diagonally through it, so here. So already, this is making a 45, 45, 90 triangle, right? Because anytime we cut a square, it makes a 45, 45, 90 triangle. So it's saying this walkway right here is 36 feet long. So we want to know how long is one side of the fence. So we're solving for one of the legs of this triangle. So it's going to be similar to the one we just did because we were given the hypotenuse and we're solving for a leg. So same thing, the hypotenuse is always x root 2. And we're given the hypotenuse, that's 36. So given the hypotenuse, so we set it equal to the pattern of the hypotenuse. And now we're going to solve for x. So we're going to divide by root 2 on both sides to undo the x root 2 multiplication. So root 2 divided by root 2 is 1, so it cancels. So x equals 36 divided by root 2. But remember, we learned that when we rationalize, we get the radical off of the denominator and into the numerator. So this is back to the notes that we took first. So we're going to multiply by root 2 over root 2 to get that radical off the denominator. When we multiply with fractions, you multiply across the top. So 36 root 2. Root 2 times root 2 is root 4. The square root of 4 is 2, so 36 root 2 over 2. And then 36 divided by 2, that's just 18. So 18 root 2 feet. All right, I know that's the end of the problems that were on there. I wanted to do just one more with you, just because I'm not here to help you when you have questions on your practice. So I'm going to make up one more problem that'll maybe help you guys out a little bit more. Let's see. And I'm going to put it where we have some blank space, right here on the front of your notes. So go ahead and write this one down too. Go back to the front of your notes. Let's draw ourselves a little triangle. I'm going to draw it this way with the right angle up top. All right. Okay, so let's say that we're given a leg. Let's say that we're given this leg right here and that it is 3 root 5. Okay, and we want to know what the other leg and what the hypotenuse is. Well, we know that the legs are always the same. So if one leg is 3 root 5, the other leg is 3 root 5. And then how do we find the hypotenuse? Well, the hypotenuse is always whatever the leg is times root 2. That's what we see in our pattern. The hypotenuse is whatever the leg is times root 2. So now we can use our multiplying with radical skills. So the 3 stays outside. Root 5 times root 2 is root 10. So the hypotenuse to this triangle would be 3 root 10. And the legs would both be 3 root 5. Alright guys, so this video is going to be up on Canvas, so if you need to go back and rewatch it because you didn't understand, please do that. Also, please help each other out since I'm not there so that you can understand as much as possible. You're going to get a... well, actually first, I'm going to have you guys get your Chromebooks out and go to quizzes and do the quizzes that's posted on Canvas. Be sure that you use your real name so I can check and see who completed it or not. And then after that, you're going to have a short practice. The practice is, let's see, 9 questions long. So I'm going to have you guys do the practice. Once you've finished that, you're going to go talk to your substitute, show them your practice, check it with the key to make sure that you practiced correctly, and then you can be done for the day. All right, so quizzes first. Use your real name so I can tell who completed it. Then you're going to do the practice, check it with the sub, check it with the key, and then you're done. All right, thanks guys.